There is a wide variety of tooling used for shaping these days. Whether you are using one-piece tool bodies or multiple-piece insert sets, care must be taken when handling tooling. While tool bodies may be made of steel or aluminum, the cutting edges are a steel alloy of some type. The simplest of these is high-speed steel. This material is very sharp and will give clean cuts. However, it has largely been replaced by carbide, which will last much longer, especially when machining composite materials. Carbide is very hard and brittle. In its raw state, tungsten carbide is a powder which is shaped into its final form with heat and pressure, using cobalt or nickel as a binder. Carbide can either be brazed on or may come as an insert which is rigidly clamped in place. Brazed carbide is exposed to heat when being applied to the steel tool body. As a result, it is not as strong as insert tooling. Tantung is similar to carbide with the addition of various minerals. It provides greater wear resistance in solid wood, but quickly breaks down when exposed to adhesives in composites. The Tantung cutters in our lab feature yellow tool bodies and should only be used for machining solid wood. Like regular carbide, these tools can be resharpened, but the diameter of the tooling is reduced with each sharpening. Insert tools have become very popular because inserts can quickly be replaced, reducing downtime caused by sending out tools to a sharpening service. Care must be taken when installing inserts to ensure they are securely fastened. A loose insert spinning at several thousand RPM can severely injure or even kill an operator. Follow manufacturer's instructions when changing cutters, including installing them to the proper torque settings to avoid problems. One final material available is diamond. Known for its extreme durability, diamond tools are capable of long run times without needing to be resharpened. Common profiles may consist of straight cutters, matched sets, such as these cope and stick cutters to produce mating joints, and multi-sets, which can be arranged in different configurations to produce various profiles. There are a number of accessories used to mount tooling onto a spindle and control the depth of cut. T-bushings are used when a tool with a larger bore diameter is installed on a smaller spindle. Because they introduce additional bore tolerances, they should only be used if you do not have a matching spindle size. Two bushings should be used at all times, unless a single bushing can fill most of the bore. Spacers are used to fill the space on a spindle above and below the cutter. Shims are used between cutters to get a more accurate fit. Tooling should be installed as low as possible on a spindle. There will typically be one or two spacers below a tool and as many spacers as necessary to get to the proper height of the threads or top of the spindle. Be sure to leave enough thread for the nut to be fully engaged with all the threads. Here, there is a small space between the end of the threads and the top spacer. This will not allow the cutter to be properly tightened. If it looks close, add another spacer. Install the anti-reversing washer, if your machine has one, and make sure the spindle nut creates compression on the tool so it does not spin freely. If you are using a bearing, small diameter and minimal thickness spacers should be used above and below the bearing to ensure that compression is only on the inner raceway of the bearing so it is able to spin independent of the spindle. Documenting setups with detailed notes and diagrams will reduce future setup times significantly. Spindle speed is defined as the number of revolutions per minute, also known as RPMs. Depending on your machine, there might be no option to adjust the spindle speed, a belt and pulley system providing two or more speeds, or an electronic speed control providing a large range of spindle speed settings. Spindle speed is dependent on the cutter diameter. If we spin each of these cutters at the same RPM, the rim speed of the large diameter cutter will be much faster than this small diameter cutter. In other words, at a given RPM, the distance this cutter must travel in one revolution is much greater than the distance this cutter must travel. If the rim speed of the tool is too slow, less than 40 meters per second, the cutter will not have enough force to sever the material and may result in the stock kicking back. If the rim speed is too fast, the tool can be damaged or the material may burn. Tooling manufacturers generally recommend that tooling be run at rim speeds between 40 and 70 meters per second. Machines often have a chart like this one to help you determine the proper spindle setting. If your machine is not labeled, consult your machine manual. Tooling will often be labeled with its maximum safe operating speed. In this video, you have learned that tooling comes in multiple configurations and materials. Quality tooling is an expensive investment. Handle tooling with care. The use of gloves is recommended to reduce the chance of injury and will prevent oils on your fingers from causing rust. Store your tooling on a rack or a drawer where it will not come into contact with other tooling or metal surfaces. Taking care of your investment will ensure more reliable results.